Now, we're going to be looking at circle theorems in this class. We have two theorems on the board and a circle to explain them. Now, over the years, students have been complaining that they don't understand circle theorems. They don't understand geometry generally. And the reason for this is not far-fetched because students are not able to interpret shapes. And sometimes when they do, they're not able to translate it into solving problems. And so it's very important we pay attention to know and understand these theorems so we can help use them to solve problems. So let's go. We have this shape. We have PQAB, a circle with x1, x2. O is the center of the circle with a common arc AB, and we have points P and Q are the points on the circumference. So we are given that points P and Q are the points on the circumference, and also there's a common arc AB. Now let's go to the theorems. What's theorem 1 saying? Theorem 1 says angles in the same segment of a circle are equal. Now, what does this mean? You would like to ask, when are two angles said to be in the same segment? When are two angles in the same segment of the circle? Is it when they are in the same part of the circle? Is it when they are on the same side of the circle? Like some students have erroneously thought. No. Two angles are in the same segment by the principle of the common arc. It is the arc of the circle we pay attention to for us to say, or for us to observe two angles in the same segment. And how do we illustrate that from here? If you look at this arc AB, this arc is producing three angles. One on the center and two on the circumference. You see it? Arc AB produced this angle on the center O. This same arc AB produced this angle on the circumference X1. This arc AB produced this angle on the circumference X2. So you see that this arc has produced three angles. One on the center, two on the circumference. How do you decipher that? Angle O is coming from point A and point B. Angle X1 is coming from point A and point B. You see that? Also, angle X2 is coming from point A and point B. So the three angles in this circle originate from the same arc, a common arc AB. Now, this theorem is saying if two angles originate from the same arc and they are on the circumference, then they are in the same segment. I'll take it again. Two angles are in the same segment if they both originate from the same arc and they are on the circumference. So you see that x1 and x2 have a common arc they originate from. So they are said to be in the same segment. Angles in the same segment of a circle are equal. When you do that by construction, you'll be able to prove that. But we're not going to be constructing in this class. In subsequent classes, we have done videos on construction. You can do well to follow our class on construction for deeper understanding of construction. But for now, let's move to Theorem 2. Now, Theorem 2 says the angle subtended by an arc of a circle at the center is twice angle subtended on any part of the circumference. Just like we said, this common arc is the central idea in this circle. O is at the center. We are saying that if an arc subtends an angle at the center, that same arc also subtends an angle at the circumference. Angle subtended by the arc on the center is 2 times angle subtended on the circumference. So AOB, this curve here means that the angle is on O. AOB is equal to 2x1. AOB is equal to 2x2. Angle at the center is twice angle at the circumference. Angle at the center is twice angle at the circumference. So the basic things you have to know in summary is that angles are in the same segment if they originate from the same arc. It can be two angles, it can be three angles, many angles as the case may be. Just trace their point of origin from the base of the circle or from any part of the circle. Trace their point of origin. If they both originate from the same point or the same arc of the circle, then they're in the same segment. Also, if they both originate from the same arc on the center, an angle is subtended, and on the circumference, angles are also subtended. The angle at the center is always twice angle at the circumference. So please, you can make a note of this, but ensure you understand what we are talking about so that in our next class, we use them to solve problems.